Yes, I'm an American climatologist that's been asked to talk about what the Copernicus Arctic Regional Reanalysis, CARA, can add to existing reanalysis information in Greenland. For the last 10 years I've been in Denmark at the Geological Survey of Denmark and Greenland. And as you can see already, there's a lot of detail that CARA is bringing, shown here, precipitation around Greenland. CARA has a high grid resolution horizontally, 2.5 kilometers. And what you can see here are vertical velocities during a strong onshore flow in South Greenland. You see a bow echo of the atmosphere encountering the topography of Greenland off the North Atlantic. You see up and down drafts in the fjords. And on the southern lobe of here, you see an updraft in which we recorded at the surface, and CARA resolves an extreme rainfall event. I wanted to show this in the vertical dimension, the 65 layers. However, the data are unavailable currently in the migration to DHS. And this underscores a data access issue. The more accessible the data become, the more users like me are not slowed down. So I'm sure you hear this all the time, but we really need to work to reduce latency. CARA has made a huge step forward for adding detail to the physiography, that is the land, surface, ice, ocean classifications. A now 100-meter product exists for all of these land surface classes that the modeling system uses to represent energy fluxes, hydrology, and even the extent of coastlines and ice was in need of some dramatic improvements in the source data that Era 5 that we know and love is using. So this CARA effort has produced products like this. I think they're being called EcoClimate 2, or it's the adjusted EcoClimate that are available for other users. The surface reflectivity albedo treatment in Era 5 was primitive, 0.85 snow albedo over all of Greenland, including the peripheral bare ice areas, which are quite dark. And so we have added satellite-derived albedo, maps without gaps of albedo daily into this, and this dramatically improves the accuracy of the surface energy budget. With Sentinel-3, we're taking this forward now since 2019 as MODIS is becoming decommissioned. We've added into the reanalysis non-global telemetry system data from a network I've been involved with since age 20. That was 28 years ago. You can do the math of my age. This data set starts in 1995, and the surface pressure, and in particular, really helps improve the accuracy of the atmospheric simulation over Greenland. The older data are the blue locations, the Greenland Climate Network. And then Denmark began the red areas, the PROMICE network, in 2008. And now Denmark is carrying forward both networks as part of its state activity. And so we are responsible for this, and we have been updating the Greenland Climate Network stations you see on the lower left with a modernized version on the lower right. And so now 40 stations are available for data assimilation, even operationally. And this was at a time when we're starting to see more extreme events over Greenland. Just 3 days after we installed this site with precipitation gauge, we're measuring rainfall at 2,850 meters in southern Greenland just 3 times already last year. The map of additional data that is not used by ERA 5 are the red circles here, and there are also contributions from Iceland and the Greenland National Survey, ASIAC. And even in northeast Greenland, there's some areas that we are filling. You can see them here. For example, these sites are filling gaps in the data series. So going forward, we have more and a higher quality of these on-ice data. CARA includes microwave radiances for vertical profiles of temperature and humidity, scatterometer winds, and sea ice that's more realistic than in ERA 5. So for all of these reasons, it's not surprising to see that the biases and variances are lower for CARA than for ERA 5 that we know and love. This is for temperature, and same for wind speed. Lower biases, lower deviations. And across the 2 CARA domains that include an eastern sector with Norway and Svalbard, for example, the green areas show where the CARA is performing with a higher accuracy than ERA 5, and just a few areas across these 2 domains where it's not outperforming ERA 5. I've focused the rest of my talk on precipitation, and I've put simple tipping bucket rain gauges on the PROMICE stations at a few locations in the south of Greenland especially, and this enables us to compare with also other reanalyses. So here's ERA 5, Japanese model, Belgian, Dutch models, and CARA, and we find that CARA has the highest explained variance as compared with all of these models, and the wet bias in the other regional analyses is not present for those measurement sites just for rainfall. So a very welcome independent verification of rainfall. And so just some research applications that I've personally gotten into involve rainfall, and just after the record-setting first observed rainfall at the top of the Greenland ice sheet last August, we published an observational study documenting the atmospheric river, a heat wave event. Atmospheric rivers are poleward, concentrated flows of heat and moisture, and we ended up finding that after the heat wave, the darkening of the bright snow-covered area prolonged the melt season by an additional week, and extending the melt season through an albedo feedback case. Here, I used ERA 5 because the CARA data were not yet available. The production latency is around 3 months presently, and it again underscores the desire to reduce latency on these types of data, because especially with extreme events that are grabbing headlines, we want to be able to bring CARA in as soon as possible. But now that the August 2021 data are available for CARA, I can confirm in that data set rainfall across the higher elevations of the ice sheet last mid-August. And in a study in preparation, I'm focusing on this 14 September 2017 event, where you can see in the yellow areas there was more than 265 millimeters of rainfall on the southern ice sheet in a single day. So flooding conditions, extreme melts was mainly driven by the heat associated with this and the really strong onshore flow. The spatial detail is unprecedented. You can notice also this offshore intensification of rainfall and kind of band structures and a lot of mesoscale features, including the fjord scale. We had, or this event had 30 meters per second onshore winds, and we can resolve these. At this scale, it's hard to appreciate the details, so you zoom into the regional scale. You've seen these vertical velocities already. And to wrap up, I'm convinced that the CARA data are very useful for documenting extreme events in state of the climate reporting. And looking once again at this mid-August heat wave event, we can track in a way that's not possible with the 40 stations on ice. The beauty of this data set is combining the accuracy of point data that have the disadvantage of incomplete spatial coverage with the complete spatial coverage of a regional climate model. Bring those together, you have accuracy and maps without gaps. And finally is to get the word out that this spectacular data set exists. There's some resources that I myself will make some amateur videos that get that out into the public, and I feel strongly that the public needs to hear as soon as possible from credible scientists of what's happening in the Arctic, and so we have a plan in place to promote CARA and get the public informed. Thanks for your attention.
Thanks so much, Jason. A question for Jason. The man of the maps without the gaps, Hans.
Well, it was not my invention, the maps without gaps. Somebody else got with it, and then I adopted it. So CARA is very high resolution, but it doesn't produce its own sea ice and SST analysis. It takes us from elsewhere. How much improvement you think if you would have a next generation, well, of course not CARA 2, but CARA 3, where you also have an ocean model and a sea ice model? Is that very important, the small details of the ice and the SST? Or is mainly the improvement you get in the atmosphere, its meteorology, is that already gives a very big jump forward?
Yeah, the importance of sea ice and a coupled atmosphere-ocean system, certainly for the declining Arctic sea ice in the Pan-Arctic CARA 2, CARA 3 domains, that certainly would be important to have a much more accurate representation of the increasing flux of heat from the more common open water. The largest warming rates in the Arctic are indeed at the marginal ice zone, and so getting sea ice right is important. CARA just has prescribed sea ice. I don't know if the concentration is adequate, but then we would need an excellent sea ice thermodynamic model exchange with the atmosphere. I don't know a lot about that, but it's got to be important.